Hi, some days ago I discovered something very important about the Euler's number, so I made a video about it, but I think people didn't understand what I was saying, so I decided to make a new video. The video is about the number e, or Euler's number. The number e is a mathematical constant approximately equal to 2.71828. That is the base of the natural logarithm and exponential function. The number is irrational, which means that it has an infinite number of decimal places and they do not repeat. Here one can see the constant e. I decided to attribute an index to each number from 2 to 8. So the index I attributed is the position of the decimal place in the number. What one has to do is to attribute an index to each place in the number e. So, for example, the number 2 is the first number as index 1, 7 is the second number as index 2, 1 is the third number as index 3, and so on. So, for the number 1, the Euler's number, the first decimal place is 2. So one has to check the index 2, and index 2 has the number 7. So index 1 becomes number 7. For the second place, one has number 7. One has to check index 7. Index 7 has the number 1. So the number we want to extract is 1. For the third place, one has 1. So one has to go back to 1 and extract the number 2. For the fourth place, the number is 8, so one has to check index 8. Index 8 as the number 8, so the fourth place is 8. At the end, what one gets is the number 71287828878. Now one has to transform this number back to the Euler's number. One attributes again the index, that is to say that, for example, 7 is in the first place, 1 is in the second place, 2 is in the third place, 8 is in the fourth place, and so on. One repeats the process, so for index 1, one has the number 7. So one must check number 7, index 7, and index 7 has the number 2. For 1, one must check 1, and 1 has the number 7. For 2, one checks 2 and has the number 1. Applying this process up to 10, what one gets is the Euler's constant again.